good afternoon, everybody, and thank you for joining for this 1 hour. It'll probably be a little bit less than a 1 hour webinar where we're going to talk about some programming tips. First off, we're going to talk about what a variable is in the C languages, and then we're going to talk into some more details about using those variables in our programs, and then making comparisons and decisions in our code so that we can start to create more dynamic applications that are really useful for starting to understand algorithmic logic and critical thinking in the classroom. So to start out, I'm going to open up CSTEM Studio, which actually opened on my second monitor here. And I'm going to go directly into ChIDE, and I'm going to start off with a brand new program. So I'm just going to go File, New, and then I'm going to save this, Save As. I'm just going to put it on my desktop, and I'm going to call it variables.ch. And just like you may already know, when we're using the CH language, the .ch at the end of a file name is incredibly important, because that's what tells the editor that we want it to display all of the syntax highlighting that we have in ChIDE. So once I've created that file and saved it, now I can start typing in my code. So before I start actually writing anything, let's talk a little bit about what a variable is. A variable is just a placeholder. So much like in math, specifically algebra, when we say x, so y equals mx plus b, and we say what is x, it can be a little bit hard to really drive the point home that x is just a placeholder. It's just a name for some value that we may or may not know. And in algebra, you could say something like 3x plus 4 equals 2 and ask the student to solve for x, and then they know the value of x. But then the inverse side of that is, once you know the value of x, you can plug it in to this simple equation to get a different result, or to verify that that is true, that x fits this equation. So much like in algebra, in programming, a variable is just a placeholder. It's just some name that we use to indicate a value somewhere along the lines in our code. For example, if I wanted to, I don't know, have a variable to indicate the number of books in a library, I could create a variable and call it number of books in the library, or n, or num, or anything else that I want, and then assign a value to it, assign a data type to it, and start to use it throughout my code for any kind of purposes that I'd like. So the first thing that I want to talk about with variables is how to declare them. So as we're programming, it's very important to understand that the program is going to start at the very top of our code, wherever that is, and run down one line at a time, top to bottom. And we can assume, for all intents and purposes, that when the program executes line 1, it's not going to have any idea what's going to happen in line 2 or 3 or 4, etc. throughout the rest of the program. So when we declare a variable, normally we want to do that towards the beginning of our program. In some cases, you may want to do it a little bit later, which we'll talk about probably in a later session. So let's say I have a variable and I want it to be the number of books in the library. So I can just type in the name number of books in the library, but in order for the computer to recognize this as a variable, I have to declare it. And to declare it, I have to give it a data type. For example, integer, or int for short. And you'll notice when I type in a data type, the editor, ChIDE, is going to highlight that red. And it's going to say, now from this point on, anywhere after line 2 here in my code, I can use number of books in the library as my variable. And what's really awesome about ChIDE, which we saw last time, is now that I've declared it, once I start typing that name, I can use the autocomplete features, where I can just hit tab and it will automatically fill in that pretty long variable name that I have there. And now that I've declared it, I can use it in any way that I want. Like I could say, number of books in the library is now equal to 20. And then if I wanted to print it out, I could say printf number of books is equal to, and then I can use our format specifiers, which are %d or %lf, %d for a digit or integer, %lf for a long float, which I'll discuss in just a moment. I could say %d and then a \n to indicate that we're doing a new line. And then I just include as the next argument to printf my variable number of books in the library and end it with a semicolon. And if I were to run this program, we can see the number of books is equal to 20. Or if I changed it to 10 and run it again, my number of books becomes 10 instead. So now if I were to do any kind of equations or anything with this variable, it will keep it up to date, but again, it's going to go top to bottom as it goes through my program. So when we're using variables, it's a very good practice to initialize those values. So if we don't initialize a value, the computer is going to automatically assign it to be 0. So if I were to run this without initializing, without doing line number 4, then we can see that the number of books in the library is 0. So there's a few different ways that we can initialize and declare variables. First, we could have done it like I did before and have the initialization on a separate line from the declaration. Or I could go ahead and put the initialization right inside my declaration statement. And that is a perfectly acceptable way of declaring a variable. And this could be for any variable type. And then let's say I wanted to do multiple variables. I could then comma separate many variables and use a single declaration statement. So I don't necessarily have to go and say int cost and then int price or anything like that. I could just add a comma here and say cost is equal to, I don't know, let's say 4.9, let's say 5 because I'm working with an integer. And then I could say price, but I don't know that yet, so I don't necessarily want to initialize it. And then anywhere in the rest of my code, I could use cost or price and they'd be declared. So I could say cost here, and just to run it, it's going to say number of books, but that's not quite accurate. It would fill in the value of cost. So before I get too much further, we have two primary data types that we use in our math curriculum. We have integers, which is any whole number from, I think it's like negative to, I don't know, some really, really large negative number and then some really, really large positive number. So I could do any whole number value. So I could say cost is instead equal to like negative 50,000. I could say price is equal to 999 whatever. Now, if I wanted to use a fraction or a decimal place, it wouldn't actually be classified as an integer anymore. Now we'd start getting into what we call a double, which is a different data type. It's a different name for a double precision, or an abbreviated name for a double precision floating point value. And what this means is it's just a decimal value that is recognized by writing in a decimal value in the computer like we would anywhere else. So I could say, instead of declaring price here as an integer, because normally your price and your cost, if you're selling something, is going to be in dollars and cents, which would be a decimal value. I could say cost is equal to 4.99. And then I could say price, I don't know, I'll have to calculate that out just a little bit later. And then so now I have this decimal value cost and this integer value number of books in the library. And if I were to print out cost, I would actually need to change this format specifier, this conversion specifier, to be a %lf. Otherwise, it's going to try and fill in an integer value, and we're not actually going to get the results that we would expect. So if I were to run this, it still says number of books, but now we see that it's printing out the full decimal place value. Just so you can see what happens if I forget to use LF instead of D, If I run this, you can see when I do %d with a double value, it's going to spit out a number that kind of looks like nonsense to us. You see it's negative, what is that? 1.8 billion, which is very, very different from 499. So let's look at why this can be useful. Suppose I wanted to create a point of sale interface for a shopping store, maybe a lemonade stand or a yogurt stand or a frozen yogurt or a bookstore or really anything. We see point of sale devices all over the place in our day-to-day lives. That most retail stores have some sort of point of sale interface. And so say we wanted to create our own. We'd need a few key pieces of information. We would need some variables to hold our cost for each item. We'd need some variables to hold how many items we're getting, and then the total price, and then we could start working in something like tax. So let's say I have a lemonade stand, and I'm selling lemonade by the cup. I could declare an integer cups, and I would do an integer because I don't want to get half of a cup. I don't want to sell someone half a cup of lemonade. I only want to sell them a whole cup. And I'm going to leave that blank for now, and I'm going to initialize that a little bit later. So I have int cups. Then I'm going to say I'm going to sell each cup of lemonade for, let's say it's a really, really good lemonade and they're pretty large cups. So I'm going to do $1.99 per cup. And then my other variables that I'm going to start by representing is the total cost. I probably want to represent the tax cost and maybe also the subtotal that we would print out, kind of like we were to generate a receipt for whoever was using this point of sale system. So in order to do this, I need to figure out how many cups of lemonade our customer is purchasing. So I could, just to start off, I could say cups is equal to, let's say I'm really thirsty and I want 4 cups of lemonade. I could then use a couple of different operators with my variables to create a different value, to do all of the mathematical calculations for me instead of having to write it out and do it myself. So when we're working with variables in CH, there's a number of different operators that we can use. We can use the addition operator, which is going to add 2 values together. We can use the subtraction operator, which is going to subtract the value on the right side from the value on the left. We can use the asterisk, which is going to multiply both values together, and then the /, which is for division, which will divide the right side into the left. So if I wanted to calculate the subtotal for lemonade, I would say the subtotal is equal to, and when I use this equal sign, this is just assignment. It's saying I am telling the computer that now, from this point on, my subtotal is equal to whatever I put on the right-hand side of that equal sign. So I could say my subtotal is equal to cups times cost. And then every single time that I run this program, it will take whatever value it has for cups and multiply it by whatever value it has for cost, and then put that result into subtotal. Then I want to calculate out my tax, and so I'd say tax cost is equal to some sort of tax rate times my subtotal. And so let's say my tax rate is 8%. I wouldn't want to just type in an integer 8 unless I were to change my math here. I'm going to do 0.08 so that my multiplication is pretty simple. And I'm going to say 0.08 times subtotal. And then when I get to this point in my code, my tax cost is going to depend on the value of subtotal from before. And so this is where order of operations in the computer starts to become very important. If I were to move my tax cost up before the subtotal, my subtotal is still 0 because it hasn't been set before we get to this line where it calculates out the tax cost. So when it runs this, it's going to say tax cost is equal to 0.08 times subtotal. Let me show you what that looks like. I'm going to use our debugging features that we talked about last month. And if you missed that, you can go back to the previous webinar that's listed on our website, cstem.ucdavis.edu/pd, and there's a link there that will bring you to it. But if I click on next, it's going to start running through these lines, and actually I made a brief mistake there and I accidentally deleted subtotal from this. But if I click step now, it's going to start running through, and what's really nice about this, as I pointed out last time, is it shows you the value of all your variables as it goes through. So it hasn't actually assigned 1.99 to cost yet, which is why cost is still 0, and all of my other variables are 0. If I click next, cost becomes 1.99, now cups becomes 4, and my tax cost, when I run through this, because at this point subtotal 0, tax cost is still 0. So I'm just going to go ahead and finish that out. And let's take a look at finishing up this really quick point of sale system for us. The next piece of useful information would likely be the total cost, and the total cost is going to be equal to our subtotal plus tax cost. And so now, with tax cost in the right order happening after subtotal is calculated, it will tell us the final total cost of our 4 cups of lemonade. Let's see one more time with the debug features. It says we're declaring all the variables, initializing cups, calculating out the subtotal, which is now 7.96, calculating out the tax cost using 7.96, which becomes 0.6368, and then the total cost becomes subtotal plus tax cost, which is 8.5968, and then we haven't actually gotten to the printing out yet, so it's still going to be printing out a little bit of gibberish. So now, if I were to finish up this point of sale, I'd want to print out some sort of nice receipt. So I could say printf receipt for lemonade with a \n, and then I could do another printf, and let's say I want to tell them how many cups of lemonade they purchased. I would say %d cups of lemonade at %lf per cup. And what I actually want to do here is I want to specify, and we'll see in a few seconds, that my number of decimal places here for cost, we want to tell it how many decimal places to use. And so the first thing that I can do is I can fill in my number of cups. So I can say cups as my next argument. And then I can fill in my price per cup, which is cost. And if I were to just run this after getting rid of my number of books, oh, I made a mistake. I need to fix this to be total cost and run this once again. It's going to say 4 cups of lemonade at 1.99 per cup. And it has all these extra zeros. I can clean that up by just doing the 0.2. And so now if I run it again, it's 1.99. And to be a little bit clearer, I might want to put a $sign there. So now I could then put on another line, printf, I could say the total for that 4 cups of lemonade is some amount of money, which is %.2lf, and I want to fill in my subtotal. And oops, I don't want that extra quotation mark there. And when I run this, now we're getting my nice subtotal there. And then I could do my tax cost, printf, and I could say tax colon $%.2lf, and then say tax cost, and then I could do it once again for my total and say %.2lf \n total cost. And when I run this, now we're printing out all of the relevant information. we're saying it's a receipt for lemonade. We're getting 4 cups of lemonade at $1.99 per cup. This is our subtotal, our tax, our total. And so this is one of the many, many applications of using variables in our code in ways that we can manipulate them to accomplish any kind of goals that we have. So let's look at some slightly more advanced operations on our variables. First off, at the top here, if I were to declare a lot more variables, or even just these 4 variables, it can be a little bit hard to read. So sometimes what I like to do is take advantage of the fact that the C languages ignore white space, and I like to add an extra variable on each line and just make sure that each line is separated by a comma. This actually allows me to do 2 things. One, I can put a comment after each variable, so I could say cost per cup of lemonade, and then I could call the next one my total cost of lemonade, and then I could say my next one is the tax price for lemonade, and my subtotal total price before tax. But then another thing that this allows me to do is to declare several variables in a much more easily read format instead of having, say, 10 or 20 continuing on a single line to the point where you might have to scroll to the right to see them. The next thing that we can do to take advantage of the white space here when declaring variables is I like to line up all of my comments together so that it's just a little bit easier to read through it, because I like to write my code for future me. So now let's talk about different operators that we can use with variables. I'm going to do this a little bit more informally, not creating a full program like I have here, and instead we're going to look at a couple of different ways that we can manipulate variables. So I mentioned just a little bit ago that our equal sign is our assignment operator. It's assigning cups to be whatever is on the right-hand side, and I could put any value that I want here. But there are other assignment operators that we can use to change the value of cups. The first one of those is plus equals. We could say cups is equal to cups plus some number. So if I wanted to add 4 cups to cups, normally I would say cups is equal to cups plus 4, but what that does is it creates a little bit more duplicate code. Instead, I could say cups is plus equal to 4, and this is going to be equivalent to saying cups is equal to cups plus 4. Let me show you what that might look like. If I click next, it starts off with cups. If I show you my debug here, cups is 0, and when it does plus equals 4, it's going to say cups is 4. Now when I hear it looks like it deleted it when I clicked next. We had cups plus 4, then it's going to take the value of cups, which is 4, and add 4 to it. If I were to do this again, cups plus equal 4, it would then make cups 12. So we start out, cups becomes 4, then 8, and then it adds 4 once again to cups. We could also do this exact same thing with the subtraction operator. We could say cups minus equal 4, and that's going to be the same as saying cups is equal to cups minus 4. So for example, if I were to think through this, this would make cups 4, then 8, and then this would take 4 away and make cups equal to 4 again. And we can verify that. It becomes 4, then 8, and then the minus equal becomes 4 again. And let me fix that error that I had there when I clicked next. So there's a few other operators that we can do with variables to do a quick assignment. We could do cups is times equal to and multiply it to itself by some number. So I could say times equal to, and this would take whatever the value of cups is and multiply it by 2. And then I can also say cups divided by equal to 2, and this would be the exact same thing. It takes cups and divides it by 2. So I could say this is equivalent to cups equals cups times 2, and then I'm going to copy this and do the exact same thing here just to leave a comment. Cups divided by 2, same thing here, cups minus 4, and cups plus 4. And I'm going to get rid of that just to make it a little bit cleaner right here. There's one last assignment operator that we can use, which is the cups percent equal to 2, and this is just going to take the modulus. It's going to be equivalent to cups percent 2, and the modulus is just going to return the remainder of some division. So if I were to start off with cups equals 5, when I run through this, it's going to do cups is equal to cups equal 5, then 5 plus 4, so it becomes 9, 9 minus 4, it becomes 5 again, times 2, it becomes 10, divided by 2, it becomes 5, and then percent 2, it's going to be the remainder of 5 divided by 2. And we can verify that. Oops, I deleted this again. I can go next through just a couple of things. So we have cup starts at 5. Then it becomes 9 because we added 4. We're subtracting 4 to become 5 again. Then we're going to multiply by 2 and it becomes 10. Divide by 2 and it becomes 5 again. And do the modulus of 2, which becomes 1, because 5 divided by 2 is 2 remainder 1. 4 and 1 half. If at any point while I'm talking during this, you can put questions into the chat on the side of YouTube there, and I keep glancing over at the side monitor just checking out to see if there are any questions. We are on a few second delay, so it may take me a few seconds to answer questions that pop up in the chat. Moving on, let's look at another way that we can use variables in our code. So I'm going to go ahead and delete these extra operators that we were doing to assign the values. Oops, I forgot to abort my code, so it was still thinking we were running. So I now am back to my lemonade stand. What if I wanted to assign some sort of a bulk discount where, say, someone was buying 10 cups of lemonade, they were buying lemonade for their office, they were really awesome, and we wanted to give them a bulk discount. In order to do that, it's a little bit, only slightly more complicated. We have to start using some sort of comparison with variables so that we can make a decision with the computer. So let's say we want to say if the customer is purchasing more than, let's say, 5 cups of lemonade, they get a 10% discount. In order to do this, I need to make some comparisons with variables. And to demonstrate this, I'm going to actually open up Command Shell. So I'm going to go back to CSim Studio, and I'm going to open up Command Shell, which is a command line interface. It's a really instant feedback for working with the CH language. And to make it a little bit easier to read on this screen, I'm going to go into my edit and then settings, and I'm going to go to appearance and increase my font size. I think I'm going to make it an 18. And so now here I can type in just about any code that I would in ChIDE and it would work almost exactly the same. The difference is I don't have to click run in Command Shell. So if I wanted to, say, create a number of cups, so I'd have to declare the variable int cups, and then I could say assign a value to it. So I could say cups is equal to 5. Now I can use some relational operators to start to compare my number of cups, this variable, to some other value. And to do this, I have 6 different comparison operators. I have cups is less than some value. So let's say cups is less than 10. It's going to say is 5 less than 10, and it's going to return either true or false. And when the computer evaluates true or false, it's just going to evaluate it to 1 or 0, 1 being true, 0 being false. So if I were then to compare cups, say cups is less than 4, we know cups is 5, 5 is not less than 4, so that's going to be false. So we have a 0 returned for a false value. So it's always yes or no when using these relational operators. So we have less than, we have cups is less than or equal to 5, and that would be true, and less than or equal to is just like the math less than or equal to, you just write the equal sign next to the less than symbol. And so if I were to say less than or equal to 4, it would return 0. We have cups is equal to, which is a direct comparison, so is equal to 5. And one thing to note with is equal to, it is 2 equal signs and not 1. So I could say cups is equal to 5. If I were to hit enter, that is 1 or true. Or if I were to say cups is equal to 3, that's going to return 0, which is false. Because remember, cups is still 5. The next ones we have are the exact opposite. We have cups is greater than 3. We have cups is greater than or equal to 3. Or cups is greater than 5, which is false. Or cups is greater than or equal to 5, which is true. Last but not least, we have not equal to. So we could say cups is not equal to 5. And this is going to be the opposite of is equals to. So if I did cups is not equal to with exclamation point equals, it would return 0 if I said cups is not equal to 5, and that's because 5 is equal to and not equals to is false. Or if I said cups is not equal to 3, that would be true as long as cups is not equal to 3. So let's look at how this can be used. When we're programming, we would want to make a decision based off of some sort of condition like that. So we may want to say something along the lines of, if the customer is purchasing more than 5 cups of lemonade, then we give them a discount. So we could then say if, and actually write the word if, and then put in parentheses. And the way this works in CH is we say if some condition in parentheses is true, then we run through some chunk of code. So I could say if the number of cups is greater than 5, then we're going to run through this next statement. And this next statement is indicated by braces or just the next statement that we write. So I say if cups is greater than 5, I could do something in here that would only run when cups is greater than 5. So I was going to give a discount. So I'm going to create another variable here. I'm going to say discount. And I'm going to call it the discount for buying in bulk. And then I'm going to say discount is equal to cups times, and let's say I did a 10% discount, so times 0.10 for 10%. And then every time that I run this, if cups is greater than 5, then it will run through this line. Otherwise, it will not. Let's see. Cups is 5. Whoops, I deleted that by accident. Cups is 5. So when I click next, it says cups is 5 here. And then it's going to calculate the subtotal. And it says if cups is greater than 5, it's going to run through this. And when I click next, it's going to completely skip over it. And you can see, if I scroll up just a little bit, my discount is still 0. And if I were to continue on, nothing else happens. But if I said cups is 6, and I were to click next, cups is now 6, and when it gets to this comparison, it jumps into this if statement, and we can check and see that the discount is 0.1 times cups. Now that calculation doesn't really make sense. Really, I would probably want to give the discount on the subtotal. So I'm going to say it is subtotal times 0.1. Then, next thing that I'd want to do is use this discount in some way. And I would want to use that discount when I'm calculating the total cost. And so I'd want to say either minus the discount because my discount is positive, or to be a little bit more explicit, I could say plus a negative discount. And I could put that in parentheses. And what this will do is it's going to evaluate this to be negative and then add it to my total cost. But then I'm not quite done yet, because if I were to run this and I were to look at my output, it says 6 cups of lemonade at $1.99 per cup. My subtotal is $11.94. My tax is 0.96, but my total is less than my subtotal. I might want to say that I'm giving a bulk discount here, so I could then add printf bulk discount colon percent dollar sign percent 0.2 LF and say discount. And then when I run this, it's saying my bulk discount is $1.19. So a little bit more advanced way of writing if statements. Normally, when you're just getting started, we recommend always using these braces. However, the computer, the way it's going to interpret this if statements is it says if cups is greater than 5 in parentheses, then run through whatever statement comes next. And so what it's going to do is it's either going to look for a section of code, which is indicated by braces, or a single statement. And so if I were to run this as is, it's going to do exactly the same thing. It's going to say cups is 6, and so when it checks this, it's going to evaluate this discount and then keep going all the way to the end. And if I make cups 5, and I were to run through this step by step, you can see when it evaluates is cups greater than 5, it completely skipped over the discount this time. And then it kept going on with the rest of my calculation. So what if we wanted to do something a little bit different if they weren't getting a discount? Like we wanted to tell them that they aren't getting a bulk discount, or that if they purchased some number of cups more, they'd be eligible for a discount. Well, I'd want to say if cups is greater than 5, then we run through, let's say, this section, and I'm going to use braces to be a little bit more clear with my sections. But then otherwise, if it's not greater than 5, I could say else. If that isn't true, I want to do something different, such as tell them that they could get a discount by purchasing more than 5 cups. I could say printf, we offer a discount for more than 5 cups of lemonade. Now it's going to say every time that cups, it doesn't do the discount, it's going to run through and tell us that we could have gotten a discount. Let's see what that looks like. So cups is 5, which is not greater than 5. And so it's going to go through my else statement, which disappeared again when I clicked next. And then it's going to print out in my output here, we offer a discount for more than 5 cups of lemonade. And if I were to just keep going through my code, it finishes up my example, we offer the discount, and then it prints out my receipt. I'm going to put that printf back there because it keeps disappearing. Now, what if we wanted to start to create a tiered discount system? Let's say instead of just saying if cups is greater than 5, offer a 10% discount, what if we wanted to give an even greater discount on, say, 20 cups of lemonade? I could, yes, go through and do another if cups is greater than 20 and run through this discount, but then we run into the problem of if it's greater than 5, we give them a discount, a 10% discount, and then if it's greater than 20, it runs through and calculates another discount. For cases like this, we have what we call an if-else-if statement, where we could say, instead of just jumping straight into the else, we could say else if, and it's going to say, if this isn't true, run through checking this next if statement. And we could say cups is greater than 20, and run through this next section of code. And so what's going to happen, you can see when I highlight this brace here, it's saying this section is from this brace to this brace, and anything that I do here is going to be only if this is false and this is true. So I could say discount equals subtotal times 0.20 and give them a bigger discount for a larger bulk order. I'm going to clear up some of my white space here, make it a little easier to read. And if I were to change cups to 20 and I click next and run through this, I'm actually seeing already that I have a slight hiccup in my code here. It's going to say cups is greater than 5, and it's going to run through that because 20 is still greater than 5. And then it's going to skip over everything else. So to fix my logic here and use this else if statement appropriately, I would want to give my bigger discount first, because I want it to check my cups to be greater than 20 first, and if that's not true, then check if cups is greater than 5. So let me change my discounts around here. And if I were to click next through this a few times, it says if cups is greater than 20, oh, that's not true because 20 is not greater than 20. If it's greater than 5, then we give them the 5 cup discount, and it keeps going on. If I were to change this and say cups is equal to 22 and step through once again, it would get to this. It would say is cups greater than 20? The discount is equal to the subtotal times 0.2 because I'm giving them 20% discount, and then it would carry on after my if-else statement. And it would give me the bulk discount of 20% instead of only 10%. And then once again, just for one final check, if I were to do cups is equal to 3, which is less than or equal to 5, whoops, I did it again where I deleted that when I clicked next. If I run through this, it says cups is not greater than 20, cups is not greater than 5, so we're going to get to this otherwise, this catch all otherwise, and say print out, we offer a discount on more than 5 cups of lemonade. So we're starting to build these programs to make decisions, and making decisions in programming is huge because it's the only way that we're able to start to create branched logic in our programs. And branching logic is incredibly important because you don't always want to give someone a 20% discount for buying something in bulk. And then there's other cases for using branched logic, which we're going to talk about in more detail, I think not next time, but the time afterwards. So I think in January, when I talk a little bit about more repetition and stateful programming. So there's only a couple more things that I wanted to touch base about here. First is you can actually start to chain these relational operators together with what we call logical operators. So we have, if I were to go back to my command shell, and I were to declare some int cups is equal to 3. Now, if I were to do a comparison like cups is greater than or equal to 3, that would return true. But what if I wanted to also make sure that cups was less than 10? I could say cups is greater than or equal to 3, and I represent and with 2 ampersand symbols, which is Shift 7 on your keyboard. I could say cups is less than 10. And if I were to hit enter here, I missed in my statement here, I missed the 3 before the 2 ampersands, and you can see it gives a pretty good error. It says multiple operands together and gives us a little bit more information there. But if I were to include that 3 and hit enter, it's going to be true because 3 is greater than or equal to 3 and less than 10. Or I could say cups equals 20 and then repeat the same comparison. And while cups is greater than or equal to 3, it is not also less than 10. I could also say if cups is greater than 5 or, whoops, I don't need the if here, cups is greater than 5 or cups is less than 3. And what this would do is it would check as long as cups is not between, or it would return true if cups is greater than 5 or cups is less than 3. So if I say cups is equal to 20, 20 is greater than 5, and it doesn't even worry about doing the other part of the or because that's true. And if I hit enter here, we can see, whoops, we can see once again the result is true. Now if I were to change cups and say cups equals 4, 4 is not greater than 5 and 4 is not less than 3. So when I do this same comparison, it returns false. But if cups equals 2 and I do this exact same comparison, it returns true, because while 2 is not greater than 5, 2 is less than 3. So we start to get into a little bit more advanced logic here. Now there's one other logical operator that I wanted to mention, and that is the not operator. And the not operator is represented with an exclamation point. And what this does is it just negates any logic statement that we have. And a logic statement is like cups is greater than 5. So I could say, right now cups is 2. I could say cups is less than 3. That returns true. But if I use the not operator and I say not cups is less than 3, it might not work in command shell. So I might have to do this in ChIDE, but I could say if, I need to abort, if not cups is less than 3, then I could print cups is not less than 3. And if I were to step through this, when it gets to here, 3 is not less than 3, so it's going to print out cups is not less than 3, and you can see it jumped into there. But if I changed cups to be 2, this negation says if, I'm sorry, I mixed up my thoughts there. It's going to say cups is less than 3, that is true, so it's going to say the not of that, which is false, and then this becomes a false answer, which would mean it will not go through printf here. One more time just to show that with the editor here. If not cups is less than 3, then it skips over that because cups is less than 3. So we start to get a little bit more complicated when we're starting to branch out our logic here, but we can see that using variables and using various operators, especially our conditional or our relational operators and our logical operators, can be very, very helpful in building out a much more dynamic program. So before I open up the floor for any questions you may have, I'm going to show you a neat little tool for helping to plan out your structure of a program. So if I were to open up a new web browser window, and I'm going to do that right now, it should show up here. I'm going to go to google.com, and I'm going to search for Lucid Chart. And what Lucid Chart is it's a chart building platform that will help us to create flowcharts for understanding how our program is going to flow through any kind of program. So what I'm going to do is I'm going to log in to Lucid Charts with a Google account. You can log in with any kind of Google account or create your own free account. And if I were to just open up any kind of flowchart diagram like I have here, we could see I can start to create any kind of flowchart diagram where I could say my program is going to start here. It's going to go through, and this one I was building for checking the age of a user. It's going to ask the user for their age. It's going to say if their age is greater than 16, and if that's true, it says they can get a license. And if that's not true, they can't get a license. And then both of these will point down to the next section of code. And you can use their tools here to build a really neat, easy to follow flowchart, and then it automatically moves the flow lines with your different pieces of the flowchart there. And flowcharts can be really, really great for helping to keep track of your logic as you're going through and building this. So I highly recommend building flowcharts, especially when you're creating more complicated programs, because if you are doing like an if else, if else, you can see how even just saying that out loud, it's becoming so much that it's hard to keep track of. Whereas if I were to do this, I could then add another else if into my line here. So you can see I could just take this and I'm going to delete it, and instead I'm just going to drag it to this decision and say else if some age greater than 20, or sorry, let's say greater than 13, and then I could do a separate true here and a separate false to start to branch out that else if, else if, else if. I see a comment here I'm trying to expand. Oh, it definitely has a lot of other uses on top of this. But that's just one little extra tool that we can use to help follow our logic as we're branching out in programming. So at this point, I'm going to open up the floor. Does anybody have any questions about what we talked about today? I'll give it a few seconds. While you're coming up with your questions, I'm going to go through and summarize everything that we talked about, and I'm just going to write it all up here on my screen. So we went through the declaration of a variable. We said we have integers, and we can do A, B, C, any kind of integers we want. We have doubles, which are double precision, especially for decimal values. So we could say double D, E, F. And then we started talking about all kinds of different operators that we can use to assign and change those variables. For example, A equals 5, A plus equal 5, which is going to add 5 to A. We could say A minus equal 5, which is going to subtract. We have a divided or multiply equal 5, a divided by equal 5, and a percent equal 5. And again, these are more advanced operators. I wouldn't recommend getting into them too early. I'd get your students comfortable with just the idea of using a variable first, and then as they're getting into more coding and they're starting to see that repetition, then I'd show them these kind of shortcut ways of labeling things. Then we started talking about making comparisons, where we said we have various operators. We have A greater than 5, A greater than or equal to, A less than or equal to, A less than. We have equal to with the two equal signs, which is incredibly important. We also have A is not equal to, which is using that same not operator that we saw before. And then we got into making decisions with those, where we could say if some condition, and we're going to say if it's true, run the next statement, which could be a section of code. And I like to indicate that with a brace on the same line, if true, and then else for if not true. And then we expanded on that with else if condition, where it says if first condition is not true, but second condition is true. And then last but not least, we looked at chaining our comparisons, where we said A is less than 5 and A is greater than 3, for starting to either create piecewise operations or just add extra checks to it. And just one last little tidbit that I want to mention is you can chain these in a condition. So we could say if A is less than 5 and A is greater than 3. All right, so that about sums it up. I don't see any questions, but you're more than welcome to reach out to me at any time that you may have them. I know we went kind of quick, but I was just trying to give a quick intro and overview of some slightly more advanced tips that we can use with programming.